Hi guys, in this tutorial I'm going to solve question number 5, paper 43, June 21. A car of mass 1400 kilogram tied with a trailer with 500. So this question related with connected two particles. So you have to know, is it horizontally, is it vertically, or is it inclined? It's written down straight hill inclined and makes an angle 5 degrees. So it's inclined. And also you have to know the system moving up or the system moving down. Makes an angle 50 degrees with the horizontal line. So the measure of this angle is 5 degrees. Down straight hill inclined at an angle of 5 degrees to the horizontal. The car and the trailer connected by a light rigid tow bar, and at the top of the hill the speed it's given means initial velocity and the final velocity is 30, but you have to know, is it constant acceleration or not. It's given that the car and the trailer moving down and the engine of the car work at, so the work by driving force is given 150,000 joule. And there is no resistance, so resistance is equal to 0. Find the length of the hill. When the system started to move from the top to the bottom. So you can write equation of the car only, you can write equation of the trailer only, you can write the system. This is forces. If we use the principle of the work done by driving force minus work done by resistance is equal to change in mechanical energy, change in kinetic energy, and change in potential energy. It's given there is no resistance, you can remove it. So the work done by the driving force, which is given 150,000, is equal to a change in kinetic energy of the system. You have to get half mv squared minus half mu squared for system, and also mgh for the system. So 150,000 is equal to half mass of the system, car with a trailer, if we add them will be 1900. So half times 1900, velocity, which is 30 squared, minus half times 1900 times 20 squared. You have to know its gain or loss. This is why I write V minus U. Whatever the sign, it's clear now, will be positive, means gain in kinetic energy, but there is a loss in potential energy. So mass is 1900, G is 10, and H, the perpendicular height, you can write the perpendicular height with S, like the length of it, name it X. So the height will be X sine 5. So you can calculate the value of X. X sine 5 multiplied by X. Simplify this equation, you can find X, which is equal to, the final answer is 196.26. So a significant figure, you can write it 196. Now by looking at the second part, it's given that instead of there is no resistance, now there is resistance force of 100 on the trailer. So for the trailer, when it is moving in this direction, when you write its equation, all the forces in direction of motion, which is tension and mg sine theta for the trailer, minus frictional force, which is resistance, is equal to ma. So you can find the acceleration. It's given the length of the hill is 200 meters. This is the length of the trailer, and the acceleration of the car and the trailer is constant. So you can use equation of motion in a straight line with initial velocity is 20 and final velocity is 30, and it's given the distance, which is 200 meters. So you can find the value of acceleration. V squared equals U squared plus 2AS. The final velocity is 30 squared. Initial velocity is 20 squared plus 2 times A times S, which is 200. From this equation, you can find the value of acceleration. 30 squared minus 20 squared. Then divided your answer by 400. So the acceleration is 1.25. If you look at the next equation, the tension, asked to find the mass of the trailer is 500 times G times sine 5 minus resistance, which is given as 100, is equal mass, which is 500 times 1.25. So you can find the value of T. The value of T will be 500 times 1.25 plus 100 minus 5,000 sine 5. So the final answer will be 289.22. 3 significant, you can write 289 Newton. This is the tension which he asked to find. Thank you.